Here we have to find the symmetrical form of the equation of the line x plus y plus z plus 1 equal to 0 and 4x plus y minus 2z plus 2 equal to 0, and hence find the equation to the plane through 1 1 1 and perpendicular to the given line. So here we can see that the given equation x plus y plus z plus 1 equal to 0. This is first degree equation in x, y, z. So this equation represents equation of plane. Similarly, the second equation 4x plus y minus 2z plus 2 is equal to 0. This is also the first degree equation in x, y, z. So this also represents equation of plane. When we taken these two equations together, so these equations represent a line. So this is the equation of a straight line, equation of a straight, this is the equation of a straight line, and this line is general form of line or non-symmetrical form of line, non-symmetrical form of straight line. So here it is given that there are two equations in first degree in x, y, z. These individually represent equation of a line, but if we taken these two equations together, this equation represent equation of a line. Here we have to convert this equation into symmetrical form of the line. We know that the symmetrical form of a line can be written as x minus alpha upon L equal to y minus beta upon m is equal to z minus gamma upon m, where alpha, beta, gamma is a point from which a line passes, and L, M, N be the direction cosines or direction ratios of the line. So for converting this equation in symmetrical form, we have to find first a point from which this line passes and the direction cosines or direction ratios of this line. So first we suppose that this is the one plane and this is the second plane. This is one plane and this is the second plane, and this is the line of intersection. This is line of intersection. Here the direction ratios of the first plane, direction ratios of the normal to the plane 1 are 1 1 1, because we know that in the equation of the plane coefficient of x, y, z are the direction ratios of the normal to the plane. Similarly, the direction ratios of the normal to the plane second are 4 1 minus 2, because in the second equation of plane coefficient of x, y, z are 4 1 minus 2. So the direction ratios of the normal to the plane second are 4 1 minus 2, and the direction ratios of the normal to the plane 1 are 1 1 1. Let us suppose that let L, M, N be the direction cosines of the line 1, and we suppose that the L and the direction cosines of the line 1 are L, M, N. Here we can see that this line of intersection and this is the normal of the plane. So we can see here this normal of the plane is perpendicular to the line of intersection. So we using here condition of perpendicularity. Here we can see that this is the plane 1 and this is the normal of the plane 1, and this is the line of intersection. So line of intersection lies on the first plane. That means this normal of this plane is perpendicular to the line of intersection. So we can see here, we can use here condition of perpendicularity. We know that condition of perpendicularity is a1 a2 plus b1 b2 plus c1 c2 is equal to 0. If two lines are perpendicular, then we use this condition where a1 b1 c1 are the direction ratios of the lines, and a2 b2 c2 also direction ratios of the second line. So here the direction ratios of the normal to the plane 1 are 1 1 1, and the direction cosines of this line of intersection are L M N. So we write here L multiplied by M plus L multiplied by 1 plus M multiplied by 1 plus N multiplied by 1. We get L plus M plus N equal to 0. Suppose that this is the second equation. Similarly, suppose that this is the normal of the second plane, and here this is the line of intersection. So we can see here this line of intersection is perpendicular to the normal to this plane. So we use here again this condition of perpendicularity. Here we can see that this is the direction cosines of this line of intersection is L M N, and the direction ratios of the normal to this plane are 4 1 minus 2. So we multiply 4 multiplied by L plus 1 multiplied by M plus minus 2 multiplied by N. We get the equation 4L plus M minus 2N equal to 0. Now we solving these two equations. Here we use cross multiplication method. So we write here L divide by, so here coefficient of M is 1, here coefficient of N is minus 2, so 1 multiplied by minus 2 minus, here coefficient of 1 M is 1 and coefficient of N is also 1 equal to M divided by, here coefficient of N is 1 and coefficient of N is 4, so 1 multiplied by 4 minus, here coefficient of N is minus 2, L is 1, so minus 2 into 1 equal to N divided by, here coefficient of L is 1 and M is 1 minus coefficient of L is 4 and M is 1, so 4 multiplied by 1. Now we solving this can be written as L divided by minus 2 minus 1 is equal to M divided by 4 plus 2 is equal to N divided by 1 minus 4. So we can write this. So we can write this here. So we can write here L upon, this is minus 3 is equal to M upon 6 is equal to N upon minus 3. Now we multiplying this ratio by minus 3, we get N upon 1 is equal to N upon minus 2 is equal to N upon 1. If we divide this minus 3 by minus 3, we get 1. This 6 by minus 3, we get minus 2. This minus 3 divided by minus 3, we get 1. Here L, M, N are the direction cosines of the line of intersection, and 1 minus 2 1. Here direction cosines are proportional to 1 minus 2 minus 1, so the direction ratios of the line 1 are 1 minus 2 1. So the direction ratios of line 1 are 1 minus 2 1. Now we find one point on the line 1. So for finding one point on the line 1, we suppose the line 1 intersect intersect the plane z is equal to 0, that is xy plane. For finding the point on the line, we suppose that the line intersect the plane z is equal to 0. So we put here z is equal to 0 in the above line, we get x plus y plus 1 equal to 0 and 4x plus y plus 2 equal to 0. Now we solving these two equations, we get the point which is from which the line passes. So suppose that this is equation 4 and this is equation 5. So here we subtract 4 from 5, we get 3x plus 1 equal to 0. So we get x equal to minus 1 upon 3. Now we put value of x in above equation, we get value of y. So here we put value of x in fourth equation, we get value of y. So y is equal to minus 1 minus x. So we put here minus 1 plus 1 by 3. So this is 2 by 3, minus 2 by 3. So the point is minus 1 by 3 comma minus 2 by 3 comma 0. Now we write here equation of line in symmetrical form. So equation of line in symmetrical form can be written as x minus alpha divided by L is equal to y minus beta divided by m is equal to z minus gamma divided by n. Here alpha, beta, gamma are the point from which the line passes, and L, M, N be the direction cosines or direction ratios of the line. So we put here x minus 1 by 3 divided by, here we can see this is 1, and y minus 2 by 3 divided by, this is minus 2, and z minus 0 divided by 1. So this can be written as x plus 1 upon 3 divided by 1 is equal to y plus 2 by 3 divided by minus 2 is equal to z divided by 1. This can be also written as 3x plus 1 divided by 3 is equal to 3y plus 2 divided by minus 6 equal to z upon 1. So this is the line in symmetrical form. Here the given line 1 are in non-symmetrical form. Now we converting the non-symmetrical form in this symmetrical line. Now we suppose that this is equal to R. Here in this question we have to find the equation of the plane through 1, 1, 1 and perpendicular to the given line. No, sorry, this. Suppose that let equation of plane passing through 1, 1, 1 is a x minus 1 plus b y minus 1 plus c z minus 1 equal to 0. This is the equation of the plane passing through 1, 1, 1. This is the equation of plane passing through 1, 1, 1. Now it is given that the required plane is perpendicular to the above line. Since required plane 6 perpendicular to the above line, so we can see that this is the required plane and this is the line. So required plane is perpendicular to this line. That means normal to the plane is parallel to the above line. So normal to the plane is parallel to the above line. So we use here condition of parallelism. So condition of parallelism, A divided by 1 equal to B divided by minus 2 is equal to C divided by 1. So suppose that this is equal to K. So from here we find A is equal to K, B is equal to minus 2K and C is equal to K. Now we put in value of A, B, C in above equation 6. So we get here K multiplied by x minus 1 minus 2K multiplied by y minus 1 plus K multiplied by z minus 1 equal to 0. Taking common K, we get here x minus 1 minus 2 times y minus 1 plus z minus 1 equal to 0. So K not equal to 0, we get x minus 1 minus 2y plus 2 plus z minus 1 equal to 0. So we get here x minus 2y plus z, and here we can see that x, this minus 1 and this minus 1, this is minus 2 and this is plus 2. So minus 2 plus 2 cancel out. We get here x minus 2y plus z is equal to 0. Here the equation is x minus thank you.